Good morning, student. Namaskaram. In today class, we are going to discuss 11th physics. So, unit name oscillation, topic name symbol pendulum. Okay. So, this is one important 8-mark question. So, in this class, we are going to discuss show that the motion of the symbol pendulum is symbol harmonic motion, and we have to derive an equation for its time period. Okay, what is the time period for that symbol harmonic motion making made by the symbol pendulum? Okay. So first of all, we have to know what is symbol pendulum. Okay. So symbol pendulum means like this is stand, this is string, this is one bob, that is mass. Okay. Okay. A pendulum is a mechanical system which exhibit periodic motion. Periodic motion means it repeat after regular interval of time. That called as periodic motion. It has bob with mass m because bob has some mass, so we can take as m. Suspended by a long string. Okay, by a long string. So that string assumed to be massless and inextensible string. Okay. And that other end is fixed. Okay. That end is fixed. That end connected to the bob. Okay. So other end fixed and a stand. At equilibrium position means that rest position. Yeah. So at the equilibrium position, the pendulum does not oscillate and hangs vertically downwards. Okay. Such position is known as mean position. So this position is called as mean position or equilibrium position. Okay. When the pendulum displaced, so we can take that bob to here. So when the pendulum displaced through the small displacement from its equilibrium position, okay, from the small displacement from that equilibrium position and released. So we can take that bob to here and release it. So the bob comes to this, come like this. Okay. 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 So it oscillates sometime and it will come to rest at some time. Okay. So when the pendulum is displaced through the small displacement from its equilibrium position and released, the bob of the pendulum execute to and fro motion. This is called, this setup is called symbol pendulum. Okay, right? Okay. So now we are assigning that L and M for that this symbol pendulum. So this is equilibrium position. This is equilibrium position. Suppose the bob, we take that bob to here. Okay. So the length of that string is L. Mass is M. This is equilibrium position or mean position. So the angle between equilibrium position to some displacement is theta. Angular displacement. Okay. Clear? Right. So L be the length of the pendulum, which is taken as a distance between that point of suspension and that bob. Okay. So this is a distance between that 2 points. That is also called as length of the pendulum. It is clear? Right. Consider one simple pendulum of length L and mass M, suspended from the rigid support, so zone in the figure. Clear? A zone in the figure, you can see mass M and L. So L means, so this is also L. Okay. So this is a displacement from this equilibrium position. Let the bob makes an angle theta with the vertical angle at some instant. Okay. At some instant, that bob makes an angle theta with a vertical at that instant. Okay. Already we know that if one object has a mass in terms of gravity, it has weights. Yeah, because yeah, W is equal to mg weights. So that object has a weights. But in terms of angle, this mg resolved into two components. Resolved into two components. Resolved means it separated into two components. Okay. So one component means mg cos theta and another component means mg sin theta. So mg cos theta here, mg sin theta here. Okay. So this is mg because always weight acting downwards. So mg in terms of theta, this m resolved into two components. And because already we know that in our physics, if force acting on some other body, if angles presented at that instant, that force separated into two components. One is vertical component, another one is horizontal component. Okay. So here also mg, because weight also force. So mg resolved into two components. One component is mg cos theta and another component is mg sin theta. Okay. So this is sting. When you place one bob or when you place one mass, there is an tension in the string. Yeah. Tension means pulse. Okay. Tension in the string that denoted as T. Tension. So tension balanced by the mg constant because both are forces but are act in the opposite direction on that bob. So one component mg cos theta balances the tension because both are acting at that object equal and opposites. Okay, both are have a equal magnitude. So T balance the mg cos theta. So that's why we are saying that mg cos theta balance the tension T. And this mg sin theta component provides a restoring force that is called as F. Okay, this mg sin theta provides a restoring force. Restoring force means when you place that object from this position to this position and release it, what will happen? That object goes here and goes here and goes here and like that. Okay. So there is a force that called as restoring force, restored to its equilibrium position because all the object wants to come to rest in position. Okay. So when you are give the disturbance, that object always wants to come into that equilibrium position or mean position, rest position. So there is a restoring force. So mg sin theta provides a restoring force F. Okay, it is clear. Okay, so from this onwards, we don't need to T and mg cos theta because they are both cancel out because they are balances. So we are only consider about these forces F, mg sin theta because it provides a necessary restoring force for this simple pendulum. Clear? So restoring force F is mg sin theta. Why minus sign here, sir? Because Force is opposite to that displacement. Yeah, object goes like here and force acting on that object and puts that object down here. Okay, down to equilibrium position. So force always acting on that displacement, but in the opposite direction. Theta means displacement. So acting in that object against the displacement. So minus sign here. We know that F is equal to ma by the Newton's second law. Yeah, we know that. Yes, F is equal to ma. So we can put it down here. So F replaced by ma, which is equal to minus mg sine theta. So here M means mass of that bob. A means acceleration of the bob. M means mass of the bob. G, acceleration due to gravity acting on that object. Theta, angular displacement from this equilibrium position. So that both M cancel out because both are mass of that same object of the bob. So we can cancel out. So now A is equal to minus G sin theta. Only one term arrived. Okay. So for this simple pendulum, theta is very, very, very small. Very small. When theta is very small, we don't need to take sin theta because theta is very small. Suppose we take sin for the theta, that value goes very small after that. Okay, so we don't need to sign for that small angle. We can take approximately as theta. So sin theta becomes as theta. So sin theta becomes as theta because so this step applicable only for that small angle. For larger angle, you have to find sin theta, but a very small angle, you don't need to find sin theta. Just to put it the sin theta value. Okay. So A is equal to minus G theta. Clear? Okay. So what is theta here? Theta is a angular displacement. Correct? Theta is the angular displacement. So this is rigid supports. This is string. This is bob. This is equilibrium position. This is some other position. This is L. This is L. This is theta. Okay. There is a distance between this position to this position that are called as X. We don't know what is the value, so we can take as yes, X. Okay. Yes, also we can put or Y we can put, but in our book X is taken out, so we can put it X here. So X is a distance between equilibrium position to that extreme position. Yes, correct. So this is X. This is theta. L means length of the simple pendulum. Okay. So displacement theta is equal to x by L. How, sir? Because we can take as for sin theta. Sin theta means opposite side by hypotenuse. Yeah. For this theta, we can take sin theta. Sin theta means opposite side by hypotenuse. Opposite side x. Hypotenuse L. Yes, x by L. So sin theta is very, very small. So we can take as approximate as theta. So theta is equal to x by L. So that's why I am putting x is equal to x by L. Already in circular motion, we know what is that arc length, radius. Yeah. circular motion. This is radius. This is radius. This is theta. This is x or L, whatever may be. Okay. So in terms of circular motion, what is the value of radius? We just sorry, for the displacement, for this displacement, this is equilibrium position, rest position, or first position. After some time, the body or object goes here. Okay, so there is a displacement from this position to this position. So theta is put it here. So x, we have to find x by r, radius into theta, r into theta, radius into angle, or radius, okay, radius into angular displacement. So x is equal to r theta, r is equal to x by r, or x by r square theta, or x by theta equal to x by theta is equal to r, or x by r is equal to theta. Yeah, correct. We can find one quantity by that known two quantities. Any known two known quantity, we can find the another unknown quantity. So for to find the r, divide the x by theta. To find the theta, divide the x by r. So r means radius, x means distance. So here radius means length. So x means distance. So distance by length is theta. It is clear? Okay. So theta is equal to x by L. So we have a one equation, that is A is equal to minus g theta. Yes. So we can replace theta by this equation. So A is equal to minus g, theta replaced by x by L. Okay. A is equal to minus g, x by L. We can rewrite this equation in terms of like this, g by L into x minus g by L into x, because g is a acceleration due to gravity. Yes, g is a acceleration due to gravity, which is constant. L is the length of the pendulum, which is also constant. X means displacement, which is not constant, because suppose you can take here, your friend take here, and someone take another position. Okay, so G by L is constant, so X is only will change. Okay, so we can take as that constant as proportional. Okay, so A is directly proportional to minus x. A is directly proportional to minus x. Proportional means constant. Yes, so we can take that constant. G by L is constant. So A is directly proportional to minus x. So this is the equation for simple harmonic motion. For the simple harmonic motion, acceleration is opposite to the displacement. Yeah, A is equal to A is directly proportional to minus x. So here also that term arrived. Hence proved that acceleration of that simple pendulum is directly proportional to their displacement. Yeah. So minus x. So hence proved that motion of the simple pendulum is simple harmonic motion, because this is the equation for simple harmonic motion, and from this simple pendulum we can arrive that simple harmonic motion equation. So first case clear. The motion of the simple pendulum is simple harmonic motion. Then we are going to move to find like a derivation of time period. Okay, derivation for time period t. So suppose one object from this position to this position, and this position, okay, goes like here. It has angular velocity. So angular velocity means omega. Angular velocity means omega. So omega is the angular velocity of that bob. Okay. Angular velocity of the bob. Angular velocity of the bob. Okay. Right. So next, its acceleration with respect to angular velocity by the simple harmonic motion and oscillation in that unit, we know that A is equal to minus omega square x. Yeah, A is equal to minus omega square x. So already we know that A is equal to minus G by L x. Already from that simple pendulum, A is equal to minus G by L x. So now A is equal to omega square x for that angular acceleration. So we can relate these two equations because both are same equation. That is for A. So we can relate. So we can relate that two equations. One is minus omega square x. Another one is minus G by L x. Yes, correct. We can cancel out x here, minus minus here. And so now we have omega square is equal to G by L. For omega, we have to take roots because so we can take a root both side. So omega square root and root G by L. Okay, omega square root. So by taking root both side, root square cancel. Yeah. So omega square becomes as omega because root and 2 cancel. So omega and root of GL, G by L. This is angular velocity. Clear? Angular velocity is equal to root of G by L. So why, sir, we have to find omega? Because to find the time period, we need the omega. Because the time period T related to omega by this equation. Okay. T is equal to 2 pi by omega. This is the relation between time period and the angular velocity. Okay. So to find the time period, we need the angular velocity. So that's why we are going to find that omega. Yeah. So omega, already we have omega is equal to root of G by L. So we can replace omega by root of G by L. Okay. So in the next step, T is equal to 2 pi by omega and 2 pi by omega means root of G by L. So this equation become as we can reciprocal this quantity. Yeah, that is like this. This 1 by G root of G by L reciprocal means that quantity reciprocal. So L by G. T is equal to 2 by L by G. This is the time period of the simple pendulum. This is a time period of the simple pendulum. So time period of the simple pendulum mainly depends on that two quantity. One is length of that string and another one is acceleration due to gravity. Okay, this is clear. So what is seconds pendulum? Seconds pendulum means a pendulum with time period 2 seconds is called seconds pendulum. A pendulum, suppose one pendulum has a time period 2 seconds for its one oscillation. So that called as seconds pendulum. Okay. So I will show you one simulation to you. So this is a simulation for the simple harmonic motion like that simple pendulum. Okay. So this is bob, and this is equilibrium position. And once suppose I am taking that bob from this equilibrium position and released. So that bob goes like here, goes like that. Okay. So in that position, oscillation, you can see oscillation. So displacement goes like that, and oscillation acts on that object in the opposite direction. Yes, you can see that. Now that object goes here, and oscillation acting on that object opposite in direction. This is simple pendulum. So period time means we can take the time period for this simple pendulum. Okay. So for making a one oscillation, it takes 1.7208 seconds. One oscillation means that called as you can see that blue trace line. This is one oscillation. From equilibrium position to extreme position and going downwards and passing to the equilibrium position and goes another end extreme position and coming into the equilibrium position called as one oscillation. So that pendulum makes an one oscillation with the time period of 1.7208 second. Okay, in 1.7 second, and that pendulum makes one oscillation. You can replace, you can increase the length, okay, length, and you can change the oscillation. So in that case, time period also will change. Okay, this is one 5 mark question. Sorry, 8 mark question. Okay, now you clear. Okay. So class finished now. Jai Hind, Jai Bharat. Thank you.